Okay, we're going to continue talking about ionic compounds. Last time we talked about how you determine the formula of an ionic compound. So if you remember, if you take a compound, for example, like lithium wants to be positively charged, and you put it with something like nitrogen, which wants to be negatively charged. And if you know the charge of each element, you could predict the formula. So this 3 would go here, and this is a 1. This would go here. So this formula would be Li3, and the way you name these is the elements that lose electrons. Their name doesn't change. So that would be still lithium. But the elements that gain electrons, their name changes to an IDE ending. So this would not be lithium nitrogen. This would be lithium nitride. So we're just going to expand on that today. We're going to talk about two things. We're going to talk about transition metals, which, as you recall, are elements that have more than one charge. Sorry, not all transition metals do this, but some have more than one charge. And then we're going to move on to something called polyatomics. Okay. So with transition metals, the difficulty is that you may have multiple possibilities. So, for example, nickel could be +2, it could be +3. So, if we put nickel, for instance, with chlorine, how would we know what would we get? Well, what you need to know is something called the numeral system, which is a way to basically identify the charge. So if you remember from last time, this means +1. This means +2. This means +3. This means +4. So if we had nickel and it was +2, and we put it together with chlorine, which is -1, the crossover rule predicts this formula, NiCl2. Now, what would you call this? Well, you would call it nickel chloride, of course. But this is the difficulty. Nickel could have been +3. Now, chlorine is always -1, so you could have had this formula. So then if you tell someone this is a compound, it's called nickel chloride, how will they know which one's which? And this is where the Roman numeral system comes in, okay? So in both cases, it's nickel chloride, but you need to put in a number after nickel to identify what its charge was. So this would have been nickel 2 chloride. This would have been nickel 3 chloride. And that identifies then, exactly what charge it had. So, for example, if I had iron 3, that would be +3. And if I put together with oxygen, that would be this formula would be Fe2O3. And I would have to name it iron 3 oxide. Same thing with copper. If I had copper, which was +2, and I put it together with chlorine, which is -1, the formula would be CuCl2, okay, using the crossover rule, and its name would be copper 2 chloride. Now, of course, you can go backwards. I could give you the name of the compound, and you could just easily derive the formula. So, for example, if I gave you copper 1 chloride, and I said, what is its formula? Then you already know what copper's charge is. You know it's just plus, and you know chlorine is minus. So then 1 and 1, the formula must be CuCl. And if I had, for instance, iron 2 oxide, well, in this case we know iron is +2, and oxygen is -2. So the crossover rule predicts Fe2O2, but remember, you reduce it and you get simply FeO. Okay, so it's really no different than what you learned before. Now, we also have another situation where sometimes you have an ion mixing in with what's called a polyatomic ion. Now, you can see a polyatomic ion. Here's just a few examples. Polyatomic ions are, the word poly means many. So these are compounds, many atoms, and that have a charge. And here's some examples. So this is phosphate. There's a whole list of them. You'll just have to remember. This is sulfate. This is nitrate. This is nitrite. This is carbonate. This is ammonium. And this is benzoate. And again, when you build your ionic compound using polyatomics, the idea is still the same. Still use the crossover rule. So I'll show you an example. So if we took, for instance, aluminum, which we know wants to be +3, and we put it with nitrate, which is NO3 minus, crossover rule predicts we will need 3 nitrates, and we will need 1 aluminum. Now, the only little difficulty here is, and this is where some students will make mistakes, is forgetting to use brackets. So you need to put brackets around your polyatomic whenever you need more than one of them. So in this case, because we need 3 nitrates, we have to put a bracket. You can see there's a bracket here around our nitrate. Okay? Now, if you only need one of your polyatomic, then you don't need brackets. So I'll show you an example of that. So if I have, for instance, calcium, just +2, and I get it together with sulfate, then -2, crossover rule predicts I will need 2 calcium and 2 sulfate, so I need 2 of each. So the 2 and 2 cancels out, so I will just need calcium sulfate. I don't need 2 sulfate, so I don't need the brackets. I just need 1 of each, so I don't need brackets there. Let's do another example. So let's say I took aluminum. Actually, let's do sodium. Sodium is positively charged, and I get it together with benzoate, which is negatively charged. You can see it's -1. Crossover rule predicts, again, I need just 1 of each. Alright, so in this case, again, I don't need brackets. So I get sodium benzoate, which is, you may know what this is. This is a preservative found in a lot of foods. Okay, there's sodium benzoate. And actually, let's just do one more. So for instance, if we took magnesium is +2, and we put it together with phosphate, which is -3. Okay, so in this case, you can see that the numbers here, they're not the same. So I'm going to need 2 phosphate. I'm going to need 3 magnesium. So this is going to give me Mg3. And because I need more than 1 polyatomic, I'm going to use brackets again. All right, and I'm going to need 2 of them. Now, in terms of names, with the ionic compounds, if you recall, the negatively charged ion has an IDE ending. That's true except here. in this case here, you do not change the name of the polyatomic. So this would still be aluminum nitrate. Okay? You don't change it to an ID ending. This would be calcium sulfate. All right. This one was sodium benzoate. Was right over here. Sodium benzoate. And this was magnesium sulfate. So again, sorry, phosphate, apologize. So again, do not change the polyatomics name to an ID ending. Okay? All right, next time we'll talk about molecular or covalent compounds.